Okay, so right now I'd like to just talk about a little bit about counting, practice counting. I know that sounds like a simple thing, but let's start off by saying that we have n numbered balls in a bag, and we want to pick little n balls. And let's start off by thinking that we have little buckets labeled 1, 2, up to little n, and we're going to pick out of our bag the big N balls. Alright? So let's first start picking them out. We'll pick one out and we'll put it in the first bucket, then we'll pick one out and put it in the second bucket. We'll pick one out and put it all the way until we have little n balls. And notice that once we pick a ball out, we're putting it in the bucket, so we're doing this with, we're picking without replacement. Okay, so without putting it back in. So how many choices do I have for the first bucket? Well, there are capital N balls, so I have n choices. Now one ball is out, it's in this bucket. How many choices do I have remaining? I have n minus 1 choices, and if I keep going all the way down, this last one, I have n minus little n plus 1 choices. So if I multiply that all together, this is equal to the number of possible choices to fill the n boxes. Order matters. Okay? And we have some notation for that. We'll write capital N parentheses little n to mean this number. Okay, capital N, this is defined as, this tells us the number of ways, the number of different choices we have here. Now, we should contrast this with what would have happened if I had picked the balls with replacement. That is, I pick the first one out, and I look at what the number is, and I write the number in the box, and then I put it back in the bag, and I shake it up, and I pick another one. So if I do that, so then with replacement, this is no replacement. With replacement, we have what? We have how many choices for the first one? We have n, then how many choices for the second one? And again, all the boxes are identical, so we have n to the little n possible ways. Okay, now, of course, n to the little n raised to the little nth power, is much bigger than this number, which is the n with the n down below. All right, so we want to think about this. We'll come back to this in a little bit, but let's erase that. And let's concentrate on this picking without replacement. Now, maybe we don't care about the order. Maybe once we're done, we're just going to dump all the balls out of these boxes and put them in a bag and hand them to someone else. And we want to know how many different possible bags are there. So, maybe we don't put them in boxes. You just pick them out and put them in another bag and hand them to someone. So how many different, in this new kind of setting, the order doesn't matter. We're going to count, so if n equaled 3, and we had 3 boxes, we'd be counting 1, 4, 3 would be the same as picking 3, 1, 4, which is the same as picking 4, 3, 1, and so on and so on. So how many different ways are there to rearrange these different numbered balls once I've decided which numbered balls I have? So there are, well, I have a total of n little n balls, and I can make a choice to rearrange them. How many are there? Well, I claim there are n factorial, which is equal to n times n minus 1, all the way down to 2 times 1. And that makes sense because for the first one, I have n choices of where to put it. So I take all the balls. I've already decided what the numbered balls are in these boxes. I take them all out, and I say, okay, now I have little n balls. I want to ask, which ball do I put in the first box? I have little n choices, so I put one. That's this n. Now I go to the second box. How many choices do I have for the second ball? I have n minus 1 because I've already used 1. So I do that, and this is how many different ways there are to rearrange them. So if I put that together, in a way, this is all the over-counting. So this counted the number of ordered ways to pull little n balls out of a collection of big N balls. And but in this one, order mattered. Now this is the number of different orders that have the same balls. So this is the redundancy. So I want to mod out, I want to divide out by the redundancy to get the total number of possible subsets where order doesn't matter. So the number of subsets of size n from capital N without replacement and order not mattering is going to be, well, it's this number divided by the redundancy. So that will be, let me write that up, it'll be this number divided by the redundancy, and so that's just n over n factorial. And if you think about it, we can write, let's put the n factorial out in front. This was just n times n minus 1 all the way down to n plus n minus little n plus 1. We can rewrite that as n factorial over n big N minus little n factorial. This is just another way to write this. And now if we put the terms together, we recognize this as something we've already defined. This is capital N choose little n, which we already understood to be the ways of picking little n items from a collection of big N items when the order doesn't matter. But now we see where it comes from. It comes from, first we pick little n items where the order does matter, and then we divide by the redundancy we get by allowing ourselves to reshuffle them around. And that's where this comes from. All right?